For every homeward turn, turn, turn. Well, it turns out that my webcam is broken.
It will not break. It will not. It broke.
That's okay. What I wanted to talk about anyway was doing actual regression with numbers. So we're going to open up Excel, take a look at it. We'll do R in just a minute. We're talking about putting a fuel additive into the rocket and how far that rocket travels. In Excel, there's a way to do regression. How doesn't really matter. What's important is here I can get my coefficient and my slope. So this is beta naught and beta 1. I'm going to use those to get my regression estimates. Here's the residual plot. Do I see any concerns in there? No, looks random, looks pretty good. Here's my yi's. So next I want to get some y hat values. These are predicted values. Remember, I'm going to be using the beta naught and beta 1 from here. So that when I do my y hats, 9.968 and 0.3293 times the x value gives me a prediction. And now I can tell Excel, make that prediction for all my data points. Here I'm going to need a y bar, and it's the same y bar everywhere, so I really only need one number. But I'm going to go ahead and calculate all of these averages and tell Excel to just store that number and use that same number all the way down. Now I'm ready. Let's talk about the SSR part. This is going to be from the regression line, which was my predicted y hat, down to the overall y bar squared. Do that for all these data points. Now let's talk SSE. This was from the data point down to its predicted y hat squared. Do that for all of them. Let's talk about SST. This is from the data point all the way down to the y bar squared. And do that value for all of them. Okay, there's all the pieces I need. Down at the bottom, if I jump all the way down to row 101, there was 100 data points, but the first row had labels, so that's why we're down at 101. I want to add these pieces up, like so. And there I'm going to have my SSE, SSR, and SST. Let's go ahead and make us an ANOVA table. Degrees of freedom, sums of squares, mean square, F. And for the regression, error, total. Let's see, 100 data points. So 99, this will be 100 minus 2 is 98. And this is always 1 automatically. Here is the piece I just calculated for SSR, SSE, and SST. And this is going to be SSR divided by, I realize dividing by 1 doesn't do anything, but I'm trying to emphasize the pattern for how ANOVA tables work. The F is this guy divided by that guy. We got a 4.34. Let's look back here. Okay, Excel already did the work for us, 4.34. Yes, we matched what Excel did, but we need to know how, so that's why we're doing this by hand. Some interesting pieces. What if I take the square root of this F value? What am I going to get? This is a t-score, 2.08. And look here, the t-score, 2.08. It did that for us. Let's look at this guy right here. What if I take the square root of him? That's going to be a measure of how much standard deviation there was from the data points around the regression line. That's a 0.44414. And up here, standard error, 0.44414. Let's try another piece. What if I take SSR divided by SST? That should be my R squared, 0.0424. R squared, 0.0424. So if Excel hadn't given me all this output, I would know how to get it, but of course it did. So why don't I just go ahead and do my hypothesis test? We can use symbols, beta 1 equals 0, or additive affects distance. Additive and distance are related. I mean, there's a lot of ways we could word this. I could do my F or my T, but I'm going to go with my F here because that's the new thing we are learning. P-value. I come here to the F distribution. I have 1 and 98 degrees of freedom. Flip the sides for an F score of 4.34. I get a p-value of 0.03983. And if we go look here at the output, 0.039, there's a little bit of rounding happening there. 0.03983 with a little bit of rounding error there. And we can say the additive does affect the rocket's distance. Now, some students have been asking, can you show us this in R? Well, sure.
Will you show them to me?
You don't want to see them?
I do. Please, please show them to me. I really do want to see them.
I just had to read in my X and Y data points into R, and then my Y hat data points are going to be 9.96808 plus 0.32930 times the X values, and my Y bar for the mean of the Y's, and then the SSR piece is going to be the sum of, let's see, SSR, Y hat minus Y bar squared. What is my SSR? 0.85653, the same answer that we were getting before. And same for doing the SSE piece here and SST. One important thing we ought to check is SSR plus SSE does indeed equal the SST, because if it didn't, that means I messed something up, and then I would have to redo the whole video, and that would be really frustrating. But now we have a way of doing the hypothesis test for regression with ANOVA by hand from the original data.